Assalamualaikum. Welcome back. Today we are going to learn about the relationship between electric current and potential difference. These are the learning outcomes from this topic. First, we are going to define potential difference. So the first word for today is potential difference. The second one is we have to explain experiment to find relationship between current and potential difference. And then we have to describe the relationship between current and potential difference. You have to state Ohm's law. Okay, you have the new law, that is what we call Ohm's law. And then draw a graph for Ohm's law. Write the equation of Ohm's law. Compare non-ohmic conductor with ohmic conductor. Define resistance. 6. Explain factors that affect resistance. 7. Solve problem involving potential difference, current and resistance. And lastly, define superconductor. Okay, this is a diagram of a circuit where current flow from the battery and lights up the bulb. Okay, so electric current flows because charge or electron flow around a circuit. What makes the electric charge to flow? So we are going to listen to a video to explain what makes electric charge to flow.
Electric potential and potential difference. We all know that electricity has an important place in modern society. It is controllable and convenient form of energy used for limitless industrial and residential applications. But what constitutes electricity? It is the flow of charge through a conductor, and the electric current is expressed by the amount of charge flowing through a particular area in unit time. Now, do you know what makes the electric charge to flow? Well, charges do not flow by themselves. Just as the water in a perfectly horizontal tube does not flow, charge in a copper wire or any other conductor does not flow itself. When one end of the tube is connected to a water tank kept at a higher level, such that there is a pressure difference between the two ends of the tube, only then the water flows in the tube. Similarly, the electrons move in a conducting wire only when there is a difference of electric pressure along the conductor. This difference in electric pressure is known as the potential difference. But how is it achieved? It is achieved using a cell or battery.
So electricity flows because charge flow. So electrons traveling along a wire. So electricity flow can be compared to water flow. If pressure is applied at one end of a pipe or wire, then water or electricity will flow out the other end. Okay. Water flows from position X to Y, that is from higher position to lower position. The pump maintains X at higher potential than Y. The difference in potential can cause water to flow and turns the turbine. Similarly, in the circuit, point X at higher electric potential than point Y. This causes current to flow from battery from X to Y and light up the bulb. So let's review. So look at our module. So diagram 7.2 shows an apple at position X and Y. So first question, compare the gravitational potential energy at point X and point Y. So of course, the potential energy, gravitational potential energy at X is greater because it is at higher position. State the direction of the movement of the apple after it is released. So the apple will move from top to bottom. So it will move downwards. State an inference about the difference in gravitational potential energy and the direction of the movement of the apple. So X has a higher gravitational potential energy. So the apple drops from higher to lower potential energy. So the apple movement is from high to lower gravitational potential energy. Similarly, in a electric circuit, so the diagram shows an electric circuit. So we have a battery, we have the bulb. First question, state the battery terminal at point A and point B. So A is positive, B is negative. Name the energy gained at point Y. So electric potential energy. Compare the electric potential energy at point A and point B. So A has higher electric potential energy than B. Electric current flows from A to B, passing the bulb in the circuit and lights up the bulb. Explain why. So this is due to electric potential difference between the 2 points. A is higher than B. So when it's higher, so the current flow from A to B. So the cell creates an electric field along the wires and maintains X at higher potential than Y. This causes the charge to flow. As the charge flows from X to Y in the field, work is done where electrical energy is transformed to light and heat energy. In other words, in order to make the current flow, the charge must have energy and we must have to do work and the charge must have energy. So the charge flow from X to Y, so we have to do work in order to move the charge from X to Y. Okay. As the charge flow from A to B, work is done where electrical energy is transformed to light and heat energy. Work done on moving a positive charge between point A and point B equals to the difference in the electrical potential energy. The difference in the electric potential energy is also known as potential difference. So first definition for today. So define potential difference between 2 points in a circuit. So the potential difference, the symbol is V, is defined as the work done when 1 coulomb of charge moves between 2 points in an electric field. Remember, 1 coulomb of charge consists of 6.25 times 10 to the power of 18 electrons. Okay. So in order to move the 1 coulomb of charge, we have to do work, and in order to do work, we have to have energy. So in other words, potential difference is defined as the energy needed to move 1 coulomb of charge between 2 points in an electric field. So what is the formula? So the formula is energy or work done per coulomb, okay, per charge. So energy or work per charge. Okay, energy needed to move 1 coulomb of charge. Or in the symbol, V equals to E over Q. E is energy, Q is the charge. Now, what is the unit for potential difference? Okay, so from the formula, energy is joules, unit for charge is coulomb, so we have joule per coulomb, or equivalent to volt, or we write down the symbol is capital V. So what does it mean of 1 volt? So 1 volt means 1 joule of energy is needed to move 1 coulomb of charge between 2 points in an electric field. So let's do one exercise. Okay, the first one. You think is a true or false? Okay, the unit of potential difference is joules per coulomb. Is it right? Yes. So joule per coulomb equivalent to volt? Yes. The potential difference between 2 points is 1 volt if 1 joule of work is required to move a charge of 1 coulomb from one point to another point. Of course, this is correct. Okay, last question. 2 volt is 2 joule of work done to move 2 coulomb of charge from one to another in an electric field. So, right or wrong? False. Okay, how to correct it? 2 volt is 2 joule of work done to move 1 coulomb of charge from one to another. Okay, in order to move 1 coulomb of charge, we need to have 2 joules of energy. Okay, so the formula V is to W over Q, or V equals to E over Q, where V is the potential difference, or in other words is voltage, W is the work done, and E is energy, and Q is the charge. Okay, that's it for today. So we continue next time. Thank you.